Okay, let's discuss the differences between the bar chart and the histogram. So the first thing Kainat told us that the bars in a bar chart, they are of same width. Okay, and you can have the bars of different widths over here. Okay, so bars can have different widths. Okay, yeah. Alaiba, what you wanted to say? Yeah. Yeah, very good. There may not be, like sometimes you do have gaps between the bars of a bar chart, but like a bar chart can have the gaps, it cannot have the gaps. So both ways it works, okay? So or may not have, uh, may or may not have gaps between the bars, okay? While here in histogram, we cannot have no gaps between the bars, okay? Can someone tell me that why we can't have gaps between the bars of a histogram? Yes, yes, Maria. Exactly. That is the reason. This deals with the continuous data. Let me write this in a different color. Histograms deal with the continuous data. That is the reason for not having the gaps. So it deals with the continuous data only, okay? The continuous data, okay? You know what is continuous data? Hmm? Yes, Mariam, what is continuous data? Or in other words, the continuous data is basically, it is the data that is collected by measuring. Like you measure the masses, you measure the volume, you measure the time, that how much time is taken, okay? So this is the data which is collected through measurement, okay? Typically you have lengths, you have times, you have heights, you have masses, the volumes, they all exist as continuous data. While the bar chart is mainly like before we go into the discussion of the continuous and the discrete data, there is another type of the data that is called the qualitative data and the quantitative data, okay? The qualitative data can be like you can be asking different students that what are your favorite colors, and maybe on the basis of that you can draw a bar chart, okay? Like here is a bar chart that is showing, okay, now this many people like the green color, this many people like the, let's say, red color, and this many people they are liking maybe a pink color, okay? So that is the qualitative data where you have the brands, I mean the different tastes, different countries, different subjects, different sects, okay? And then you have the quantitative data that is only in terms of numbers, okay? And when we talk about the quantitative data, like for example, you can have a bar chart where you're showing that there is a team, it, this team has scored 0 goals in this many matches, okay? Then it has scored 1 goal in this many matches. So this is the quantitative data. This is 0, this is 1, okay? And then 2 goals this many times, okay? So this is your quantitative data. So when we talk about the quantitative data, then it has two main types, two main categories. One is the discrete data, the other is the continuous data. The discrete data is collected by, how do we collect the discrete data? The discrete data is calculated by counting, like you want to make a bar chart that how many chairs are here in different rooms of the school. So you will be counting that, okay, here are 30 chairs, in 11B there are let's say 13 chairs. How many cars do you see passing by? Okay, how many Corollas did you see? How many Hondas did you see? So that is, you collect this data by counting the number of cars, the number of chairs, the number of fans, the number of pencils. So that is your discrete data. Okay, so we draw this bar chart mainly for the discrete data. Okay, so I had to write here the discrete data. Okay, this is for the discrete data, and this is for the continuous data. Sometimes we are asked to draw the histogram for the discrete data as well. In that case, you will have to convert that discrete data into the continuous data, because the data has to be continuous. For example, uh, let's say there is a case that um, uh, we don't give the marks in points in Cambridge. Okay, you can have 1 mark, you can have 2 marks, you can have 3 marks. You cannot have 3.1 marks or 4.5 marks. Okay, so suppose there is a situation that you're given a data, like in a class, students like getting from 0 to 10 marks. There are 5 students. Okay, and then there are, like from 11, let me take it at from 1 to 10. Okay, 1 to 10 marks, there are 5 students. 11 to 20, there are, let's say, 7 students. And then 21 to 30, there are, let's say, 4 students. Okay, when you try to draw its histogram, you will see that, look at this, what will happen here. This is starting from 1, this is ending at 10. Okay, you can have a bar like this. Okay, and the next bar is starting at 11. Okay, it's like starting from 11 and, like going up to 20. So you see there is a gap between these two bars. So if you have to draw this histogram, there should not be a gap. For that purpose, we calculate one more thing. What we call that, if this is the classes or groups, whatever you have, what do we call that? These are basically class limits here. What do we calculate to convert our discrete data into the continuous data? Class boundaries. We calculate the class boundaries. Okay, and how it is done, let me show you in this. I can share this so that I can come back to this. Okay, now, suppose this was your data 1 to 10, there are 5 people. Then from 11 to 20, there are 7 people. 21 to 30, then there are, let's say, 4 people. Okay, so since this is not the continuous data, so these are the class limits. Okay, these are the class limits. This is the lower class limit. This 1 is the lower class limit. 10 is the upper class limit. 11 is the lower class limit. 20 is the upper class limit. Okay, so you will have to construct. This is called constructing the class boundaries. Okay, how do we do that? We just find the difference. We find the difference of the upper class limit of a group and the lower class limit of the next group. So what is the difference in these two numbers here? 1. And then you half that difference. Okay, the half of 1 is 0.5. So you take off 0.5 from all these lower class limits. So you have 0.5 here, you have 10.5 here, you have 20.5 here. Okay, and then you add that 0.5 into the upper class limits. So this is going to be 10.5, this is going to be 20.5, and this is going to be 30.5. Okay, you see now your data is continuous. Now how it is continuous? Because this group is finishing at 10.5, the next group is starting at 10.5. Okay, so when you draw this, there is a method of drawing this. You just you can have the you can have here a jagging line. Okay, and you can start from 0.5. Don't start looking for that 0.5 onto the graph paper. Okay, so this is drawn on a graph paper. So you will start from 0.5, and you can, like, let's say this is 2 centimeter showing a 10. So this is 10.5. Another 2 centimeter, this is 20.5. another 2 centimeter, this is going to be 30.5, and then you will be drawing those bars over here. Okay. So now we have started talking about how to draw this histogram. Now please listen this carefully, and you can note it down that a histogram is basically a two-dimensional shape, two-dimensional diagram basically. Okay, and this has a horizontal axis and this has a vertical axis. Now you must be very clear that your horizontal axis can have only the continuous data over here. Okay, it can have only the continuous data. If you have the discrete data, you convert that into the continuous data and then you mark it over here. Okay, so your horizontal axis has to have the continuous data. And now this vertical axis. Vertical axis. How do we determine that what information has to be shown on the vertical axis? Let me take you back to that page where we were discussing that thing here. Where did that go? I was writing something here on this page. This. Where is all that working that I did here? Okay, I was telling you the difference between the histogram and the bar chart. And then the next most important difference between, it should be here. I had written so many points on it. This is not on, yaar. Is it here? नहीं, ये तो कुछ और ही है.
Sir, जब आप Zoom पे new डालते हैं तो खत्म हो जाता है.
Oh, that's really unfortunate. Okay, so when we were discussing those differences, one major difference between the bar chart and the histogram is that, let me see if you people can make me recall what is one major difference between a bar chart and a histogram. You have discussed the different bars, okay? I mean, gaps between the bars and different widths of the bars, okay? And then there is one very important point is left to be discussed. Yes? What is that point? That is the height of these bars, okay? In a bar chart, the higher is the bar, the more is the frequency. Okay, for example, you look at a bar chart like this. You see this is the bar for the A stars for you people, inshallah, when you will appear in exam. This will be your A's here, okay? And then this will be B's, okay? And then this will be C's, and bus, that's it, inshallah, okay? So from this histogram, what do you see that, what is the mode of this data? A star, because this has the highest frequency. Okay, so in a bar chart, the higher is the bar, the longer is the bar, the greater is the frequency. Okay, but in a histogram, how do you determine the frequency? No, area. That is the area of the bar represents the frequency. The greater is the area of a rectangle or a bar, the greater is the frequency. Okay, so when we were discussing that, okay, what has to be taken on the horizontal axis, it is always going to be the continuous data. Even if you have the discrete data, you will convert that into continuous through constructing those class boundaries, okay? And then this vertical axis. So what do we take on this vertical axis? Yeah, it can have the frequency or the frequency density, or sometimes we take the height. How do we determine, how do we finalize that, yeah, okay, I'll keeping frequency on my vertical axis? How do we decide that? Yeah, exactly. The fate of this vertical axis is determined by the class widths. If you have all the same class widths, you can take frequency. If the class widths are same, look at in this case, we have just over here. What is a class width? When you have drawn, when you have constructed the class boundaries, then you don't need to use these class limits anymore, okay? So the class width over here is going to be, look at this. The class width is going to be upper class boundary minus lower class boundary. This is going to be 10, this is 10, and this is 10. So it means we can keep the frequency on the vertical axis. And you can call your histogram a bar chart as well, because all the bars, they will have the same widths. And the length of those bars that is showing their frequency. Okay. Now, but suppose if it was, there was a group like this here, which was from 30.5 to 50.5, okay. And let's say this has a frequency of, class to the 15, and there is a frequency of, let's say, 10 over here. So then you will, in this case, you cannot have the frequency on the vertical axis. You will have to calculate the frequency density, okay? So the frequency density is, this basically determines how dense is the frequency. That is directly related to the area of that bar, okay? So the frequency density is going to be the class frequency over the class width. You can see that the class frequency is going to be that how it is spreaded over that class width, okay? The class width is, oh, sorry, thank you, beta. This is 20 here. Oh, yes, this is 20. Okay, so now you calculate the frequency densities and then you draw it. Let me show you some already drawn histograms here, okay? Let's go back to the book. Yeah, okay. Now you look at this, this data over here. Age, A years, and you see this is how you write the continuous data, okay? And this is down here, this is the discrete data in this. So he has, did he draw that? Let me see here. Okay. Mass is from 40 to 50, and the mass is from 50 to 70. So there are two groups. So this is mass, continuous data. Okay, there is no need for the class boundaries here. Look at the number of children, the frequency. This is 40, this is 60. So can I keep the frequency here on the vertical axis? No, because the class widths are different. He has taken the class widths as well. So then we have calculated the frequency density. So that is how you will have your histogram. You can see here that jagging line drawn to show that this part is out of the scale over here. Okay, so this is out of the scale here. Okay. Now look at this data here. You have 12.5 to 13.5. You have all these class limits here. You have been given the frequencies. You have to, like, whenever you are required to draw a histogram, you are bound to show all this table over here. That is, there are marks for this. Okay. So, so here is the exercise, guys. Chale, please try these first three questions. Okay, after you have done this question number 1, I am interested in question number 2's last part. Let me draw its histogram quickly and then I get back to you.